Very good. Thank you very much. And greetings from Carlsbad, California. It's 6 o'clock at night here. So we're going to be presenting on the rapid lateral flow assay, a new generation that we've developed. So it's utilizing a microarray spotting and the IgLoo reader. So let's look first what the beauty of the current rapid assays are. They're well-known, accepted technology, been around for 20 years plus. Billions are sold every year. And they're fast, single-use, point of care, and they're mostly accurate, but they do have a number of problems with them, which we'll get into next. So the not so pretty side of the standard lateral flow assays right now. They're difficult to multiplex beyond a few assays. If you try to do more than 2 or 3 lines on a strip, you get a lot of chemistry issues, get interference between reagents. So some lines will come out darker than other ones. So they also currently need a reader, which can be very expensive, and it's to remove the subjective readings and to qualify results. There are new phone apps, though, that have come online now, which have been pretty nice. But part of the problem is that they don't necessarily have the precision and sensitivity needed. Plus, the different phone manufacturers will routinely change the cameras within their phones without telling you, so then the software has to be updated or requalified with it. The results also need a human touch to enter to the patient's electronic health record, whether it's human or veterinary or whatever the system is used. That means it doesn't interface well, if at all. And no permanent record of results if the reader is not used, and it's very subjective. So let me talk now about the new generation of lateral flow assays and what we've done. So this new generation will use micro and nanodots instead of lines. And I'll be showing you a picture of that in just a few moments. It uses an inexpensive, less than $500 US reader to interpret the data. That's called the IgLoo system. And again, I'll be showing that to you in a moment. And the reader connects directly to the electronic health record or other devices. So let's look at the IgLoo real quick here. We'll do a 1-minute video so you can see how it looks. So basically, a drop of sample is put into the sample recorder and then run just like a regular laboratory. This IgLoo also allows the different analytes to be done in different reporter molecules. So you can use fluoride, gold, carbon, you can also use an enhancement, you can use protein platinum. So it can be multiplex, that's a multiplex there. You can use different types of sample types as well. So there now the program's going to show you a little bit of the lab grade accuracy inside of it. Yeah, go ahead and move it in. It's getting stuck. I'm sorry. Okay, the video didn't load very well, but it'll be on the presentation, and you can look at it on YouTube. So here's our platform. We have the reader, which is here, the IgLoo. You can see it's very small. And then we have the cassette. And if you look on the cassettes, you'll see that we have a lot of dots there. Those dots correspond to what used to be the lines, the test and control lines. So it's very easy to multiplex. We don't know how many we can do on each one yet. That will depend on various chemistries that are involved. But we can do maybe up to 9 to about 15 different assays. Those different dots then correspond to quantitation as well as qualitative results that can be done. So let's look at the benefits now. So the benefits by using microdots, we have more assays that can be multiplexed to form true test panels. The interference of chemistries going with microdots or the nanodots are not the same as with the lines. We don't have the same issues. And the data is obtained for all assays on the test cartridge, which is a very important aspect of the test. And I'll have more on that to follow here. So the user cannot interpret the test results without the use of the reader. On a standard lateral flow, of course, they see the test line, they see the control line, and they're able to get the results that way, even though it may be subjective. So by having the user where they can interpret the test results themselves, there's a new marketing avenue which is established, and that's basically getting all the data from the cartridge. So let's say we have a cartridge with 9 different assays on it, but their user only wants to have 1 or 2 of those known to them. So they pay for those 1 or 2, and then we also have all the other 7 though, as far as the data results that are done for it. So let's look at the first product that we're going to be introducing, which is the SafePath vaccine stepper. It's called the core vaccines, and they're required in many parts of the world. So the results for the client are affordable, convenient, and meaningful. That is, they can do the test in 10 minutes at the doctor's office with no hands-on experience or necessary except for just putting the sample into the port. But by using the microdots and using the IgLoo to interpret it and get all the data that comes, we are generating population data. So that's real-time, actionable, and previously unattainable. So let's do an example now. Does my dog need to have a booster for canine parvovirus? So in order to run the assay, you enter the animal's information on the on-screen form, which will be tied into the IgLoo. You pay for the assay, you run the 10-minute test, and you receive the results. So you want more results? All you have to do is pay for those. We've run all 4 of those assays on the strip at the same time: the parvovirus, the distemper, the adenovirus, and the rabies. Even though you may have the client may have only wanted one of them, we have the data and we'll store the data for all 4 of them. So let's look like to the benefits of to our company as well as to the partner that we have with it. So we get revenue from the testing performed just like you would for any standard lateral flow. But also we have the collection of results from all 4 analytes on the vaccine array. Now there's a lot of vaccine companies now that used to have their vaccines as multivalent, where they would have 2, 3, or maybe all 4 of the vaccines in one boost. But people don't want to do that anymore because animals are becoming over-vaccinated. So they're doing individual vaccines now, but they don't necessarily have the data as the vaccine companies for how well the vaccines are doing in individual animals, different breeds, different parts of the world, and different lot batches. So now we have a potential revenue from sale of data to third parties like the vaccine manufacturers. When we're allowed into the electronic health record of the pet, we know the pet's not only the pet's name, its weight, its age, its breed, and we can also then access the vaccine history so that we know, let's say it's done a rabies vaccine, is that the one batch that was looking at, that was on the electronic health record, didn't do as well as another batch. This is the type of information that specifically we can sell to a vaccine manufacturer. But remember, this test can be used in a lot of different ways in a lot of different industries. So to recap, we've developed a simple, inexpensive point of care platform that can generate real data real time and collect this data for analysis. So this platform can be used in veterinary diagnostics, like we showed with our vaccine array. It can be used in human diagnostics, as there's a lot of panels. It could be COVID, flu, different types of panels like that. And the samples can be serum, urine, sputum, or it can be stool assays once it's been purified a bit. Environmental analysis is also, since it's point of care, it can be used in that area as well. And then in industrial processes. So this platform has a lot of different uses depending on the area you want to go into. And that's it for the slide presentation. We're happy to take any questions now.